because you're potentially thinking about how you're going to deliver the building very early on in the process, you inherently start to look at how you can make things work more effectively. So, for instance, if I can have a structural element that also becomes the carrier system for the services, rather than split my building up into sort of discrete zones of structure, plant, ducting, pipework, cabling, if I can start to compress those and say, how can I get a smaller component which does all of those functions, you can reduce the amount of material in the building fundamentally. You potentially build less building because you can start to consolidate what are normally big volumes of air that you don't no longer have to heat and treat. And that sort of thinking of how can I get more effective goes right through the process. So for instance, in the construction phase, something like 30% of building materials typically end up in a skip, because materials are brought to site, they're measured, they're cut, we throw things away. With design for manufacture and assembly, we see that figure coming down to 1 or 2%, because things turn up in a very controlled fashion, they're assembled in a very controlled fashion, there's no waste, there's no things that need measuring and throwing away. So again, that sort of philosophy of how can I do more with less, how can I deliver that with fewer vehicle movements, fewer people running around site, less waste, all of that has a huge impact on not only the construction sustainability, but potentially the long-term operational sustainability, because you've designed a building which is leaner, which is more agile, which has better functionality.